A very easy question, guys. You've got to find the value of x and y so that these two vectors are equal. What do you mean by two vectors equal? Look at that. I have 2i plus 3j, and you have another vector which is xi plus yj. So when can I say two vectors are equal in a sense? If they do have the same direction ratios, they are equal. It does not matter where exactly they are. The position can be different because they are free vectors. But if they have the direction ratios same, then I can call these two vectors to be equal vectors. Now, in this case, if these two vectors are equal, of course, the component of I here is 2 and the component of I here is x. So x is 2 and y is 3, and that makes a simple sense. I can say that these two vectors are equal. Now, look at that. These are two-dimensional vectors. We can actually use the board to understand this. If I have this vector, 2i plus 3j, where exactly is that? I can say that if the vector is from 2i, it means 2 units positive in the x-axis direction, and 3j, it means 1, 2, and 3. So this vector is nothing but 2i plus 3j. Okay, that's a vector OA. Now what happens? What happens if at all I have a point here, A somewhere here? Okay, and now I have another vector which moves like 1 and 2 units to the right, and from here it goes like 1, 2, 3. So this vector again, let's say this is point B and C. So if I say vector BC here, how do you write this guy as a question? This is moved, the direction cosine or direction ratios of this vector, basically it means what? The point B has to move 2 times I in the right side or the positive side of the x-axis, and it has to go 3 times up, or it has to go 3 times j up, like that. That's 2i. Now look at that. Even this guy is having the same components, that is 2i plus 3j, and this guy is 2i plus 3j. It means this guy is 2i plus 3j. Can I say that these two vectors are equal? Of course, right? But they don't start from the same point. This vector is from the origin. It is also the position vector of A. But there's a vector which is formed by joining 2 points. But are they equal vectors? Of course, yes. Why? Their components are like 2i plus 3j. Yes. And here also it is 2i plus 3j. We also call them to be the direction ratios in 2 dimensions. Right? If I just have the direction ratios same, wherever the vector is, it doesn't matter. I can say that these two vectors are equal vectors. Keep that in mind.